Hey, what's up you guys? It's your boy Sean, and in this video we're gonna go through ionic bonds. Have you heard of the term opposites attract? If you've heard of it before, you most likely know what it's gonna be like. So here's an example. Here's a guy and here's a girl. This guy really likes the girl, so he decides to give the girl something. And the girl likes it, so they form a special feeling called love. This transforms the relationship to another level into a relationship with, the double apostrophes. If you can understand this, you will understand the way ionic bonding works. Say for example, the metal is a guy and the non-metal is a girl. The metal gives the non-metal electrons, and this in turn forms something special. It's not called love, it's called the electrostatic force of attraction. And this relationship is known as the ionic bond. Here are the four main things that we need to go through for IGCSE. Let's take a look at the periodic table. Choose two, one metal and one non-metal. So I'm choosing sodium and chlorine over here. And as you can see, sodium has 11 electrons and chlorine has 17. So I'm going to write it down here. Sodium has 11 electrons, chlorine has 17. To put it into its electronic state configuration, it will be 2.8.1 and 2.8.7. And as we all know, these atoms want to be stable. They want to be stable. So how can they become stable? It's either that their first shell have 2 electrons, or their second, third, fourth, fifth, and so on shells will have 8 electrons. So let's take a look at sodium over here. It has 1 outer shell electron, and chlorine has 7 outer shell electrons. This means that both of them are not yet stable. So sodium will give chlorine his electron, and this forms 8 electrons on the outer shell for chlorine, and if we were to draw the second shell for sodium, there will be 8 electrons as well. So both are now stable. Sodium will then become positive and chlorine become negative, because sodium loses an electron and chlorine gains an electron. So here's the definition. Again, I'm going to draw the diagram over here so you guys can imagine it. Now, using this diagram, let's answer the question. It is an electrostatic force of attraction, which is the love part, formed between positive metal ions, because it loses an electron, so it becomes positive, and negative non-metal ions, which gains an electron, so that's why it becomes negative. And this is due to the transfer of electrons. Okay? Now, once we get this definition set, I've highlighted the parts whereby the marks will be given in the exam. Next, we move on to lattice. So lattice is some sort of a community, if you could say so. It's a community of ionic bonds. So take a look at this salt crystal I have over here, NaCl. If I were to zoom in close, you would see that there are positive and negative ions alternatingly arranged next to each other. So plus minus, plus minus, plus minus, plus minus. So this gives rise to the definition of alternating patterns of arrangement. Okay, it's an arrangement of atoms, of ions, of positive metal ions and negative non-metal ions. Okay, it's alternating, and this is held together by something called the electrostatic force of attraction, which is the love between positive and negative ions. Okay, great. Let's take a look at what is being highlighted. Alternating patterns of arrangement. That's what gets you the marks in the exam. So there we go. That's an ionic lattice. Let's take a look at the properties now. There are 3 main properties of ionic compounds. So here they are. First one is they have high boiling and melting points, because when they have a relationship, this special relationship, it forms a really strong force of attraction. Ionic bonds are really strong. So what happens is you need a lot of energy in order to break down these bonds. So you need a lot of energy to break down the love that metal has for non-metals. The second one is that it is a great conductor of electricity. Electricity flows when there are presence of free moving ions or free moving electrons. In this case, free moving ions. So these free moving ions can only be seen in liquids and not solid ionic compounds. So that's really important for you to remember. Why? It's because these free moving ions in liquid can move around and can carry the electricity. And the last one, and that is the solubility in water. So ionic compounds are soluble in water. Just like how NaCl, your table salt, dissolves in water, ionic compounds can dissolve in water as well. So that's it for ionic compounds. I hope you guys enjoyed it. Keep studying easy, keep studying lazy. Adios.